Hello everyone, in this video, we're talking about caching techniques. So what is cache? Cache memory is a small memory, fast and located to the CPU. Temporary stores copies of frequently used data from the main memory, reducing the time the CPU needs to access the data. Just to improve the performance of computers by minimizing the access delays. What this actually means is that with a cache memory, it is located close to a memory, to the CPU. So when the data is used from the main memory. It stores it inside the cache memory. Hence, for the CPU to access it again, it doesn't need much time to access it. Get access to it very quickly. Hence, improving performance and execution time speeds up. Also, we have cache mapping techniques. What are cache mapping techniques? They are decided techniques for which data is being stored inside the cache map. We have the direct mapping, the fully associative mapping. The direct mapping, it maps each memory block to a specific cache line using model. While it is simple but it's prone to conflicts. With the associative mapping, any block can go into any line in the cache, reduces conflicts but requires complex hardware. We have the cache placement process. This is where data, some of the data, this is where some of the data that are stored in the cache memory needs to be replaced with the incoming data. We have the LRE and then the FI, F, and then the random. With the LRE, which is the least recently used, it replaces the block that hasn't been used in the longest time. This is when a memory that has been in the cache memory for, a specific amount of time longer than. Actually, it replaces the block that has been used in the longest time, meaning for another data to come inside the cache. What the system does is that it replaces it replaces the data that has been stored inside this memory for a longest while, for a long time, and then hasn't been used for with the new incoming data. For the FIFO, which is the first in, first out, replaces the block that has entered the cache for the first time. Hence, when the data is being stored in the cache and then another one is coming in, it gets rid of the one that comes in first and then replaces it with the one that is coming in. And then we have the random one. It replaces a randomly selected cache block. Yeah, it doesn't have to deal with the last one that has been there for a while or the first one that comes in. Just randomly selects any block at all and then replaces it with the next incoming memory. We also have cache write techniques. With the cache write techniques, we have the write through, the write back, and the write around. With the write through, data is waiting to move the cache and the main memory at the same time. What this mean by that? When data is moved into the cache memory, it saves it in the cache memory and then it saves it to the main memory also at the same time. With the write back, data is waiting only to the cache and then updates the main memory later on, which means it doesn't write or it doesn't update the cache memory and the main memory at the same time. It updates the cache memory first and then later on updates the main memory. With the write around, the data is waiting only to the main memory, bypassing the cache. Hence, data is not stored to the cache, but then stored only to the main memory at a specific time. Then it doesn't also later on update the main memory to the cache, but then it only updates the main memory. Data is only stored inside the main memory. And these techniques determine how important updates make. Moving on, we have the cache performance matrices, which actually evaluates cache efficiency. It means it sees or but sees how the cache memory works effectively. So we have the heat ratio. It is the percentage of memory accesses that are found inside the cache. It's the percentage of memory accesses that are found inside the cache. That's already explained itself. With the miss ratio, it is the percentage of accesses that must go into main memory. We also have the access time, time taken to fetch data from the cache of memory, and this is very important. This is very important. With the least time taken to fetch data from the cache memory, faster the execution or the better the performance of the CPU. So higher times leads to slower executions or poor performance. This is very important when it comes to the access time. Hence, cache makes that very easy. Okay, so higher heat ratios and lower access times. So in conclusion, effective cache strategies can significantly speed up computing system. Understanding mapping replacement and write techniques is very important, essential for improving memory performance and overall system efficiency. So this is all I have for you about caching techniques. Thank you.